In this video, we are going to discuss about the diagonal relationship between lithium and magnesium. The relationship is based on the atomic size and ionic size of these two respective metals. So the first similarity or the diagonal relationship is based on the hardness of these two metals. You'll find that these two metals, they are quite hard. And the next similarity is based on the formation of bicarbonates. Basically, these two respective metals, they do not form solid bicarbonates. Another similarity is based on the effects of heating of carbonates of these metals. Remember, carbonate is different from a bicarbonate. So when you heat a carbonate of this metal and a nitrate of these two metals, what will happen, or what will be the products of the process? In simple terms, when you heat the carbonates of these two metals, you will form the carbonates of these two metals decompose to form an oxide of these metals and carbon dioxide. For example, when you are given a case of lithium carbonate, you will form a lithium oxide, an oxide of lithium and carbon dioxide. The same is applied to magnesium carbonates. Then the next was based on the effect of heat on nitrates of these two metals. When you heat the nitrates of these two metals, you will form oxide of these two respective metals. The next similarity is based on the solubility. The solubility of these two metals. In other words, the compounds that these two metals form. First, you find that local and magnesium chloride are soluble in ethanol. This is due to the covalent character that they do form. So another point that we can add on the solubility, the Florides and the hydroxides of these metals, when you add it into water, basically they are sparingly soluble in water. So the fluoride and hydroxides of these metals are sparingly soluble in water. Then another similarity, we can talk of the strength of the bases of these metals. These two metals, they form weak bases. When you want to identify the strength of the bases of these metals, you look at the pH scale. In other words, the weak bases have got lower pH, while the strong bases have got higher pH value. So another similarity is based on the effects on heat of when you react nitrogen with these metals, you will form ionic nitrates. Like for example, when you react lithium with nitrogen, you will form lithium nitrate. So basically, those are this few discussion about the diagonal relationship between lithium and magnesium. Next time, we'll talk about the importance of sodium and potassium